Hello guys, in this video I'm gonna explain to you the concept of a series connection. So for two or more elements in an electric circuit, we can connect them in what's called series connection. Okay? So I'm giving here examples, for examples basically, as you see in the screen, for two resistances, R1 and R2. But this is like valid for any type of elements, capacitors, inductors, resistors, voltage source, current source, whatever. Whatever the electric element, you can connect it in series or in parallel or basically neither of them, as we're going to see in the future. So the series connection, has like two conditions. First of all, the two or more, elements that are in series should have a common terminal, a terminal that is, part of the first element and also part of the second element. And the second condition, they must have the same current. The current that is passing through the first element can't branch, can't go anywhere except to continue to the second element. Okay? So two conditions. First one here, they have a common terminal. Second condition here, they have the same current. Same current. Okay? So let's check, for example, the first example here, R1 and R2 straight, So R1 has a terminal here. Let's call it V1 or, yeah, V1. Okay. And the second terminal is actually this one here. Remember, guys, from the last video, we said that a wire that has nothing in an electric circuit is basically a short circuit. And the short circuit has equal voltage, whatever, the location on the short circuit. So the voltage, for example, here is exactly like here, is exactly like here. Okay? So that's basically one node, we can say. So we're gonna say, or we're gonna call this one, which is this terminal, V2. Okay, where is the terminal of R2? R2 also has two terminals. I'm gonna call this one V3 and here V4. Remember, in between V2 and V3 are on a short circuit, right? So if you have like two nodes on a short circuit, this is actually one node, one terminal. So basically V2 is V3. V2 and V3 is just one node. Okay? So we can replace both and call that node, for example, V. Okay? So look now, R1 and R2 has a common node, common terminal, which is V. And the current that goes through R1 can't go anywhere except to continue in R2. So if there is a current flowing like that, it just continue and pass through R2. So they are really in series. Let's see or check the second example. I just modified the shape a little bit, but if you remember from our last video, in electric circuit, we don't care about geometry, we just care about connections. So that's exactly equivalent to the first connection of R1 and R2. And again, R1 has two terminals, this one here, let's call it V1, and that one, let's call it V. Because again, that short circuit is just one node. And R2 has two terminals, one of them is V, and for example, the second one, let's call it V2. And if there is a current, let's now change. If there is a current flowing in R2 like that, it will continue. It has nowhere to go except to continue into R1. So it's still, this is a series connection. Actually, the first and the second circuit, these two circuits, are actually the same. I just changed the shape, geometry, how we draw it. But Again, we don't care about the geometry. Okay? You can draw R1 and R2 in any like shape, but still they are in series. And of course, this is also equivalent. Same. I just make it like, a curvy. That's fine. Again, this is V1. This is all of this is just one node. Let's call it V. All of this. It's just one node. Yes, I drew it like a wire, but for us in electric circuit, ideally a wire is just a short circuit, a node, 1 point. But you can elongate it. You can draw it in any way. And R2 has two terminal V, and let's call this V2. And if there is a current flowing, for example, in that way, it will just continue and go through R2. They have the same current. There is no way to go for this current except to pass through R2. And again, this one is also series. Just draw it in any way, as long as they have a common terminal and the current pass through any of them has nowhere to go except to continue to the other one, they are in series. So one first observation here is that if you have a series connection, the current must be the same, through all the resistors or all the elements, whatever the element are. So if you have like a resistance like that, resistance like that, resistance like that, until, for example, you reach, this is R1, R2, R3, until you reach, for example, Rn. This is, for example, VA, and this is VB, the first terminal and the last terminal. The current here, let's call it I1. Let's call this one I2. Let's call this I3. Let's call this IN. This is series. So the first rule here, I1 equal to I2 equal to I3 equal to IN. Actually, you can just call them I going through R1, I going through R2 until I going through Rn. That's the first rule. Now, let's check the equivalent resistance. Okay, I have two resistances. If I want to simplify the circuit, can I remove these two resistances, or three or four, whatever, and put just one resistance? And the answer is yes. Okay, so if you have two resistances, R1, R2, between VA and VB, you can draw it in that way. VA, VB, and this is, for example, R equivalent. And R equivalent will be R1 plus R2. How about if I have like, two equal resistances, R1 is equal to R2. In that case, if R1 equal to R2, then the equivalent resistance R equivalent is equal to 2R. Let's call them R1 is equal to R2 is equal to R. So in that case, R equivalent is equal to 2R. If they are 3, 3R. If they are 4, 4R. And so on. So again, the general here, for N resistances, between VA and VB, R1, R2, Rn, R equivalent will be R1 plus R2 plus Rn until you reach Rn. If R1 equal to R2 equal to R3 until you reach Rn, in that case, R equivalent equal to N R. Let's call again. R1 is equal to R2 equal to R3 equal, until Rn equal to R, for example. So NR. Okay? Very small observation here. R equivalent is always, or must be, you can say, must be larger than the highest resistance or the maximum resistance in the combination. Like let's take an example. So the rule here is that R equivalent must be higher than or larger than R max, or the maximum between R1, R2 until you reach Rn. For example, let's take an example here. Three resistances between, again, two terminals VA and VB. This is equal to, for example, R, or let's take 1 ohms, 2 ohms, 3 ohms. So R equivalent here is equal to 1 plus 2 plus 3, which is 6 ohms. And 6 ohms is, of course, larger than 3 ohms, which is the maximum resistance. This one, the maximum resistance. Okay, guys, that's basically it. That's the series connection. Okay? Common terminal, same current. R equivalent, the sum of all the resistances. Okay? If they are equal, it will be R equal to NR. R is any one of them. Okay? And finally, R equivalent must be larger than the highest resistance. And they have the same current. Okay? Thank you very much for watching and see you in another video. Bye-bye.